Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the channel Chandan Physics. In this video, we are going to discuss voltage divider bias. Let's begin. To study voltage divider bias, we have to consider an NPN transistor that is under common emitter configuration, that is emitter, base and collector for that of NPN transistor. That resistance Re the resistance Rc but in base the resistance used two resistors as R1 and R2. Point potential plus VCC. It is grounded. The current flow IC, emitter current IE, base current IB. This is a point potential. So, potential at that point also plus VCC. This end is grounded. We can take the current flow along through R1 and R2 and I1 be the current along that circuit. The potential on emitter base junction is the input junction, that potential V base emitter, and potential on collector emitter junction, that the output junction, collector emitter junction. That type of biasing is known as voltage divider biasing. Why? This type of biasing, this circuit is known as voltage divider bias circuit. Because the potential divider is formed by resistances R1 and R2 by resistance R1 and R2 biases the transistor. That circuit we call as voltage divider bias circuit. Basically, we do biasing for what reason? To fix the Q point, that is known as the operating point. If the Q point is fixed for a particular transistor, then that transistor is said to be properly biased, means it is working perfectly. If any fluctuation occurred in that of Q point, then the transistor is not perfectly functioning. That method, voltage divider bias, is such method to fix that Q point. Let me mathematically show the coordinate of Q point, that is collector current and voltage along common voltage along collector emitter junction, that the coordinate of Q point. We have to calculate IC and VCE mathematically. Look at that circuit. Let I1 amount of current flowing through that of resistance R1. So, that current some along base and some along R2, and the current flowing along to that of base is very small. As we say that current also along that of R2 is I1. Let the current flowing through resistance R1 is I1, as base current IB is very small. So, what happened? Therefore, it can be assumed that the current flowing through R2 is also I1. Therefore, the value of I1 and the potential is the point potential VCC divided by equivalent resistance R1 R2 connected parallelly. So, the equivalent R1 R2 are connected series. So, the equivalent resistance R1 plus R2 at the amount of current along the resistor R2. Then the voltage drop across resistor R2, voltage across R2 is V2, and that voltage is equal to current into resistance. Current I1, current I1, resistance R2, or V2 is equal to value of I1 as VCC divided by R1 plus R2 whole into R2. Now, to get IC, we have to apply Kirchhoff's voltage law on that of input junction. Input junction is the emitter base junction. Applying KVL, Kirchhoff's voltage law to input junction. Here KVL is applied. The potential at R2, that potential at V2, here the potential VBE minus VBE. Next, the potential drop across RE, that is IE into RE, IE into RE is equal to 0. Therefore, since we know emitter current is very similar, the amount is nearly equal to that of collector current. Instead of IE, we can substitute IC, V2 minus VBE minus IC RE is equal to 0, or the value of IC we can evaluate. So, IC RE is equal to V2 minus VBE, or IC is equal to V2 minus VBE divided by RE. Put the value of V2 here. IC is equal to value of V2 is put, that is VCC divided by R1 plus R2 whole into R2 minus VBE whole divided by RE. One of the coordinate of Q point IC is evaluated. Equation number 1. Again, applying KVL to that of output junction, that junction is collector emitter junction. Again, applying KVL to output junction, that of output junction, it is VCC, potential drop at RC, IC into RC minus IC RC, that is collector emitter potential VCE minus VCE, potential drop across RE, IE into RE minus IE into RE is equal to 0, or our requirement is VCE. As you know, IE is nearly equal to IC. Instead of IE, we can substitute IC. VCC minus IC RC minus VCE minus IC RE is equal to 0, as IE is nearly equal to IC. Taking IC as common, VCC minus IC as common, that is RC plus RE minus VCE is equal to 0, or VCE is equal to VCC minus IC whole into RC plus RE. Is equation number 2. In this way, the coordinate of that operating point is easily evaluated. So, what will be the importance of that kind of biasing? Look at that expression number 1. In that of expression of IC, there will be no such term of beta, means the transistor parameter. Transistor parameter play an important role for stabilization of transistors biasing. As there will be no term of beta, so we can say that voltage divider biasing method is an useful method for transistor biasing stabilization. For that reason, that kind of biasing accepted universally. We write it. It is clear that in equation number 1, IC does not depend upon beta, that is transistor parameter, which is the amplification factor. Thus, IC in that circuit is almost independent of transistor parameters for that reason, and hence it provides good stabilization. Good stabilization is ensured. Due to this reason, that type of biasing, that potential divider bias, has become universal method for providing transistor biasing. that one is an advantage of voltage divider bias. So, with the help of this video lecture, we understand one of the biasing method in case of transistor biasing stabilization, that one is voltage divider bias. This is the circuit, why it is called voltage divider bias circuit, and mathematically we calculate the value of IC and VCE by taking Kirchhoff's voltage law in input as well as output junctions. IC and VCE are nothing but the coordinate of Q point or operating point. By analyzing these coordinates, we can easily fix that Q point, or we can say it as operating point, and that Q point play an important role for transistor biasing. One of the very good advantage of that type of biasing, since it does not depend on transistor parameters, so it is used as universally. So, with this useful and informative notes, let me wind up this session. Thank you.